So if you'll observe, till last class we studied what is canal rays, same way what is anode rays, there is what is cathode rays and anode rays and their properties. And finally we studied what is the properties of electron and what is the properties of proton. Same way, now today's class we are going to study after discovery of electrons and protons, some scientists came forward to give their predictions for the structure of atom. So that is what we are going to study in our today's class. What is their predictions and what is their experimental proof and how they have been compared. What is the limitations of their comparisons? That is all we'll discuss it. So if you have noticed it, last chapter we studied the first scientist who described about the atom. Anyone can remember and tell me? All of you? Last chapter it will be coming. So scientist name who has been given a model of an atom. We used to study that. Any one of you? Yes, please. At least one of you also not remember. You studied model atomic theory. Somebody scientist name called as Harish.
Sir, Dalton, sir.
Yes. So, as we are studied Dalton atomic theory, you might be notice it. Have you remember that, all of you? Last chapter. So, in his Dalton atomic theory, Mr. Dalton said that first point, atoms are what, guys? Atom is indivisible, but later on, this concept was discarded or diluted, like it is not believed due to the discovery of electrons, and the same way due to the discovery of protons. So till that people used to believe atom is indivisible. As soon as once they discovered the electrons and protons, so his theory become failure. So it is not a valid point. So like that, so many drawbacks of Dalton's atomic theory is there. We already studied. Next, so that is why the electrical neutrality of the atom proves that there are equal number of electrons and protons in every atom. So if you have taken atoms of any element, suppose if you have taken hydrogen atom, it is having one proton and how many electrons, guys? One electron. If I have taken helium atom, hydrogen, if I have taken helium atom, two protons and two electrons. Same way, if I have taken carbon atom, it is having six protons and six electrons. So like this, the electrical neutrality, that is why atoms are electrically what charge? Positive or negative or neutral? Anybody? Yes, please.
Neutral, sir.
Neutral charge. So that is what? So no positive charge, no negative charge. So because for every atom, it has been proved that number of protons is equals to number of what? Anybody? Number of electrons. So their charge is same, but they are opposite. One is positive and one is negative. So that is why the atoms are electrically neutral or they are neutral in charge. But new question arranged. How these atoms are arranged? Means these electrons and protons are arranged inside the atom. Then only many scientists they propose different atomic models. So do you remember this all the models, but by the time of discovery of these models, no neutrons has been discovered. Please remember J.J. Thomson model and Rutherford model. These all the models at this time, they know only two subatomic particles. What is the two subatomic particles? Everybody? Only
Electrons.
electrons and protons. So they don't know the neutrons. Even Bohr's atomic model also, by the time of this, all the models, nobody knows the neutrons. After that only, neutrons has been discovered. So that is what you have to remember. So how the atoms are neutral in nature? Because it has been proved that number of electrons and protons are equal or different. Everybody, yeah,
Equal.
they are equal in every atom. So with this, so many scientists came in that the first atomic model was given by Mr. Again, the same famous personality of us, that is what Mr. J. Thomson. So that is only called as the first well-known atomic model called as Thomson atomic model, or we can say Plum Ding model. Please write. So we'll start, everyone. So this is the first atomic model given by, again, who has been given? Everybody. Johann, Mr. J. Thomson. Okay. So this is only also we can say plum pudding model of an atom, or also we can say, all of you remember, watermelon model. So these many names we are having. Watermelon model of an atom. So according to this model, what he has been concluded, what is this atomic theory? So let us understand. So according to Mr. J. Thomson, by the time of Thomson, only two subatomic particles we know. What is the two subatomic particles? Everybody? All of you, Sanjay, Kaushik? Electrons and as well as protons alone. Yes or no? So now observe the first point. He considered an as positively charged sphere because positive charge is uniformly distributed. So he said that first atom itself a positive charge. You understanding? An atom is considered as positively charged sphere because positive charge is uniformly distributed. Okay, so he considered atom itself is a what, guys? What charge? Positive charge or negative charge? Positive charge. Understanding? Then he said that the electrons are embedded. Embedded means anybody meaning? Embedded means arrangement, guys. Arranged in this positively charged sphere. Positively charged sphere. So later, this both points has been proved wrong, and one and only valid point which we are considering till today. Of course, J. Thomson never proved anything with the experiment. That is why it is just a theoretical model. We'll study only to know the history. Other than that, we don't have any use of J. Thomson model in present world. So the third point which he considered, that is what stability of the atom or electrically neutral. So he said that in any kind of atom, if you have taken any kind of atom, the total positive charge, the total positive charge is equals to which charge, guys? Is equal to the total negative charge to maintain the electrical neutrality. So this is the only valid point of Mr. J.J. Thomson. So this is what is J.J. Thomson atomic model. In exam, they will ask you for 2 marks. So many times it is. Write the J.J. Thomson model, atomic model. So you have to write these 3 points. Understand, Mr. Danishkar? Harish? Anyone having doubt, please ask me. Clear, Gokul? That is what? What is the first point? He consider, now you'll understand what is that. So nothing is there in J.J. Thomson. What we have to take? We have to take one sphere. All of you keep it in mind. So if you consider atom itself is a what charge? Positive charge or negative charge? Yes, please. Atom is positively charged. Understanding? So you consider atom itself is a positive charge. So this is what? And if you have taken, all of you observe, this atom itself is a positive charge, and he said electrons are arranged inside it. So that is what he has been said. So if you consider, for example, this is the atom. So entire atom, what charge? What charge he said? Everybody. He said it is what charge? Positive charge. Understanding? Now, inside it has been arranged. A small things has been arranged. That is what we used to say electrons. So electrons are arranged inside this positive charge in embedded. That is a word we can say embedded. Clear, everyone? Please respond. Like this, it is arranged. So this is what we used to call as Thomson model. So Thomson said the same thing. Sphere itself is considered as what? Everybody? Positive charge, and the electrons are embedded in it. So this is what you have to remember. Now, and finally, what he said, amount of positive charge is equals to what? Amount of
negative
charge. So it has been stable, electrically neutrality. That is what Thomson model. So you have to remember this yellow color, how I made. This is what he has been said. What is this? Negatively charged electrons. They have been embedded. Embedded means arranged, guys. Electrons and the electrons are spread throughout. Electrons spread throughout. And this red color one, what we used to call, everyone? The space filled, remaining empty space. The space is filled with what? What charge? Filled with a positive charge. That is what you have to remember. So this is what Thomson model. Okay. Now he compared this Thomson model first with one famous Christmas cake. What is that name called as? Everybody? Pudding cake. So that is what we are going to study now. He compared this J.J. Thomson atomic model with the plum pudding cake, and same way as well as with the watermelon. So let us discuss first comparison with the plum pudding. Comparison with the plum pudding. So we all know Christmas pudding. Do you remember, everybody? Yes, please. I hope you all know Christmas pudding cake. Yes or no, guys? Nobody knows? Hello,
Yes, sir.
Yeah. So that Christmas pudding cake, entire cake is considered, that cupcake or whatever it is considered as positive charge. And in that we are using the cherries, and as well as that what we can say, that red color one. What is basically red color, or different things will be there. what is that called as, girls? Dry fruits. That dry fruits and all will say. So that is what is has been considered as negative charge. So you can see what is this pudding cake he has been made it. So if you consider any kind of cake, now even Christmas cake, observe that the entire cake is considered as Christmas pudding cake. You might be noticed that the cherries and all we used to consider as a negative charge, remaining entire cake is considered as positive charge. If you have taken, for example, this one, so you might be noticed that dry fruits and all. He said these dry fruits are arranged inside this pudding cake. This cake is called as positive charge, and these dry fruits which are arranged is called as negative charge. So that is what we will say comparison with the plum pudding. So J.J. Thomson compared the atom with this Christmas pudding cake. You can see this cake. Dry fruits, wherever you are seeing the middle, that is what negative charge. Dry fruits present in the electron, represent the electrons, and whole pudding cake is represent which charge? Everybody? Yes, please. Positive charge.
Positive charge.
That is what you have to remember it. That is what Mr. J.J. Thomson has been said. Please write. J.J. Thomson compared the atom. J.J. Thomson compared the atom. J.J. Thomson compared the atom with the Christmas pudding. In which the dry fruits represents what, guys?
Negative charge, sir.
Yes, represents the electrons. That is what negative charge. And the whole cake is considered, whole pudding cake is considered pudding as positively charged. That is why this model is called as, at J.J. Thomson model also we can call it which model? Plum pudding model. Please remember that. Danishkar, understand Danishkar? Abhirami? Anything doubt? Please ask me. So also we can say charge rate is plum pudding. Whole pudding has positively charged atom. So you please can draw a Christmas cake or anything, just a normal pudding. So in that you can represent this whole whole thing you consider as a positive charge, and you can take, basically it will be black in color, so that you can draw whole this is the Christmas pudding cake, and middle you can draw small cherries, dry fruits and all. So that is what we can say it is the electrons. Okay, so this is the Christmas pudding cake. And the electrons you can draw as a cherries or some other dry fruits. That's all it is. That is what it is. Next, Mr. J.J. Thomson compared the same atomic model with another one. That is what we used to call as watermelon. So comparison with watermelon, B. So now we are all eating watermelon. Yes or no, guys? Have you noticed that the seeds are arranged inside? Yes, please, Mr. Omar, Abrami. when we are eating watermelon, the red color edible part, if you have taken, if you cut the watermelon into so many different parts we can cut. If you cut the watermelon into round shape, you might get the watermelon will be like this. Is it yes or no, guys? Yes, please. So that edible part, what we are eating, that edible part is considered as positive charge, and the black seeds, where the black seeds are arranged, the black seeds, it has been called, what has been called? All of you, that black seeds only wish to say it is electrons. So you can consider that black seeds, I'm not representing with the electrons, just I'm making, I will turn it into black color so that you can understand. So this is what the seeds. So you can take this black color seeds is considered as, okay, where it is present inside the watermelon is called as electrons. So this is what Mr. J.J. Thomson compared this watermelon model. So if you notice it, that edible part, what we are consuming, red color one, is called as positively charged, and this black color seeds, how they are embedded, that is what arranged, or we people will say embedded. Please learn embedded, then that is called as electrons. So he compared this with this watermelon model, the red edible part, what we are eating, eatable part is represents which charge, guys? Positive or negative charge?
Positive charge.
Charge. And this black color seeds represents what? Black color
Negative.
represents, okay, representing a seeds in the watermelon. Seeds represent negative charge. That is what you have to remember. So write this model. I understand diagrams, everyone. So we have to just try to draw. Nothing is there. In exam also you can draw nothing. Right. He also compared the atom with the watermelon. He also compared the atom with a watermelon. The red edible part of watermelon, the red edible part of watermelon represents the positive charge in which the electrons are embedded just like seeds, just like the seeds in watermelon. So please write. So this is what, that is why this model also we can call it as what? Watermelon model. Okay. So this is what J.J. Thomson model. In the exam they'll ask, you have to write the first 3 points, same way Christmas pudding and same way watermelon model. So please make it everyone. Completed? All of you write till here. Anything doubt anyone can ask. Clear, guys? All of you? Is it okay, ma? Now,
Yes.
so what is the limitations of Mr. Rutherford? That is what we will study now. So what do you mean by limitations? Anybody can tell me? Limitations means what? Anyone, please? Limitations means drawbacks. Please remember that. They will ask you in exam, limitations or drawbacks or whatever it is. Yeah, disadvantages. Everything you have to write the same thing. Limitations of J. Thomson's atomic model. Okay. So now it has been said just now. I said he has been spoke like orally, predicted. Is there any experimental proof for this? Everybody?
No, sir.
No. So that is what you have to remember. So the one and only valuable prediction by Mr. J. Thomson, one and only prediction. What is the prediction? Third point. What is the prediction? All of you, atoms are electrically what? Electrically neutral. That is the one and only valid prediction done by Mr. J. Thomson. Other than that, remaining all the points, it is wrong only. That is what the limitations of Mr. J. Thomson model. So limitations are disadvantages, or we will say drawbacks, all the things are same. So first point, right, he could not give any experimental, he could not give only prediction, no experiment. He could not give any experimental support to his model. That is why we will study only for historical purpose, no use of this model. Okay. So that is why this model of atom was rejected by other scientists as it is lack of any experimental support. So that is what other scientists not accepted his theory. Okay, because no experiment proved. And he is not explained the particular properties of atom, how they have been arranged and what way they have arranged. That is all. Just he said that positively charged one atom itself a positive charge and electrons are embedded. How they embedded? What pattern they embedded? That is all he has not explained. That is why it is also a disadvantage. He could not explain. He could not, Mr. Aswardham, understand? He could not give or he could not explain. You can write. That is the correct word. He could not explain the spectral properties. That is what particular, how the arrangement and all, he has not explained, electrons and all. Spectral properties of the atom. So that is what it is. So these are the disadvantages. So only one and only valid prediction. What is the valid prediction by the Mr. J. Thomson? Everybody? Yes, please. All of you. What is the only valid prediction?
Atoms are electrically neutral, sir.
That is what. Right. Spectral properties. So the only valid prediction, the prediction of electrical neutrality of atom was accepted. Atom was accepted and found to be a valuable contribution. Other than this, remaining is nothing is there. So this is what is the limitations of Mr. J. Thomson atomic model. Hope all of you understand. Harini, Tejaswini understand. Shruti. So in exam also they'll ask you what is the limitations of J. Thomson model. You can write this, and what is J. Thomson model. You can write these first 3 points, and also you can explain comparison with the plum pudding and comparison with the watermelon. So this is what is the first atomic model called as J.J. Thomson atomic model. Understand, Omar? Anything doubt? Kaushik, Danishkar, Akilan, please make it.
Understood, sir.
Write it. Completed? Then we will go to the next one. Okay, so this is the first atomic model. Then the second atomic model, that is what? Discovery of nucleus. So you have to write, even exam they'll ask you, discovery of nucleus means you have to write the same thing. That is what? Rutherford's alpha particle scattering experiment. Make it, everyone. Rutherford alpha particle. Alpha symbol is this. ALPHA. Alpha particles scattering experiment. This is only we can say discovery of what? Everybody? Discovery of nucleus. Okay. So please keep reading. Now, so if you'll observe this one, so after J.J. Thomson model, the discovery of electrons increases the curiosity of scientists about the structure of atom. So as soon as the electrons has been discovered, by whom? Who has been discovered electrons? Anybody? Yes, please. Who has discovered the electrons? All of you. You forgot. Who has been discovered electrons? Electrons are discovered by J.J. Thomson. Understand? And protons are protons are discovered by whom? Protons are discovered by
Goldstein, sir.
Eugen Goldstein. Please remember scientist name at least. Now, as soon as the discovery of electrons, like done by Mr. J.J. Thomson, then all the scientists, their curiosity is turns towards to the structure of atom. What is the secrets of this atom and how it has been present? All the properties, arrangement of electrons, how the inside the atom is everything. Like this questions increases the curiosity to know the structure of the atom. So the secrets of this atom were revealed by Mr. Ernest Rutherford after the initial attempts of Thomson to explore it. So once Thomson has been given his model, Mr. J.J. Thomson has been failed to give the experimental proof. So that is why Mr. Rutherford came forward with the experimental proof to prove that what is the structure of atom, how this positive charge and negative charge has been arranged. So that is what his experiment has been firstly accepted experiment to study the properties of atom, internal properties of atom. So what's his name? Ernest Rutherford. All of you remember that. The scientist name called as Ernest Rutherford. So he was actually born in 30th August 1871 in New Zealand, and he is one of the most prominent scientists. Even at the age of 16 itself, he has been completed his he has joined in a big schools in that New Zealand, and Rutherford awarded a scholarship also. He is a very bright student, and so many investigations of scattering of light he has been done. And finally, even for the discovery of nucleus, he has been awarded a Nobel Prize also. Nobel Prize in 1980. Because why I'm saying this? Because they will ask you the question in government exams and any kind of things and all. So because of discovery of nucleus, he has been awarded Nobel Prize in chemistry at the year of 1908. Okay.